This video provides an overview of the installation, features, and usage of the Model 768 Auxiliary Interface Panel. For the remainder of this video, we will simply refer to it as the AIP. The AIP is intended for use with the current generation 760 series phase selectors only. There are other AIPs, namely the 1030 and the 758, that were used with previous generation phase selectors. They are all similar but not interchangeable. As the name implies, the AIP provides additional interface options for the 760 series phase selectors. The use of the AIP is not required unless you need one or more of the functions that the AIP provides. It is, however, a recommended accessory in all installations, or it can always be added later if the need arises. Mounting the AIP is easy. There are slotted holes along three sides of the AIP. Mount the AIP to an available spot in the traffic cabinet using either installer supplied screws or spring clips. The AIP includes a cable to connect to the 760 series phase selector. This cable is keyed and includes jack screws. Both ends of the cable are the same. The rest of the connections are made using installer supplied wire and/or cable. Next, we will describe the functions provided by the AIP and how they are connected. We will discuss them starting with the most commonly used to the least commonly used. The first is GreenSense. GreenSense allows the phase selector to monitor and record which traffic signals are green during the EVP or TSP call. Keep in mind that making these connections may expose you to 120 volts AC, and loosening the field terminal wires may cause the conflict monitor or MMU to put the intersection into flash. Follow your jurisdiction's guidelines as to whether the intersection should be put in flash while making these connections. If jurisdictional guidelines allow, make any given phase connection while that phase is red. To connect GreenSense, you will need to run a 16 to 22 gauge wire between the field terminals for each green phase in use in the cabinet to the corresponding AC in terminal on the AIP. We can monitor up to 8 phases. It is recommended to not connect any phases not in use. Remember to also connect a wire from AC neutral to the AC common terminal on the AIP. Many installers will use an extra piece of Model 1070 cable to make this connection. 1070 cable is the cable used to connect a Model 3100 radio GPS unit to the phase selector. Once connected, you will want to verify the connections by using the current activity screen in OnSite. Along the bottom left corner of this screen is the real-time view of what the GreenSense inputs are seeing. Compare this to what is displayed on the traffic controller or conflict monitor /MMU. Up to 16 additional preemption outputs are available on the AIP. These may be used in addition to or instead of the outputs that reside on the 760 series phase selector. To use these outputs, run a 16 to 22 gauge wire from the desired output terminal on the AIP to the input in your traffic controller. You will also need to run a wire from one of the logic common terminals on the AIP to the logic common input in the traffic cabinet. You will only need one logic common connection regardless of how many AIP outputs you use, but you will need at least one. The logic common wire on the 760 phase selector is only for the outputs on the 760 series device and does not provide that connection for AIP outputs. You will then need to use the output screen in OnSite to assign the output to the desired channel and turn signal status if used. Notice the pull-down choices for outputs on each channel and for each turn signal option. Listed are both the 4 standard outputs that come from the back of the 764, as well as the 16 additional preemption outputs from the AIP. Next, we'll review the use of the AIP to connect advanced IR detectors. Anytime more than one infrared detector is connected to a channel, the signal from the second and third detectors should be connected via the auxiliary detector input on the AIP. The AIP provides connections for 2 auxiliary detectors for each of the 4 channels. Although it is possible to land signal wire from more than one detector on the same terminal, it is not recommended. By using these inputs, it is possible to set range independently for the auxiliary detectors versus the primary detectors. It is also possible to see which detector is seeing an emitter signal on the current activity screen. The input column will indicate if the signal is coming in on a primary input versus one of the auxiliary inputs. The auxiliary detector connector also provides additional terminals for detector power and ground, but you may use the power and ground connections that the primary detectors are connected to. If your installation uses confirmation lights, it is possible to control them directly from the traffic controller or by using the confirmation lights outputs on the AIP. In order to use this feature on the AIP, it is necessary to connect GreenSense as described earlier. The AIP outputs are intended to drive either a relay or a load switch, which then controls the connected confirmation light. See the installation manual for details on these connections. There are 4 confirmation light outputs, 1 from each direction. If you wish the behavior of the confirmation lights to change based on which green signal is being displayed, it will be necessary to also connect the GreenSense so that the phase selector can know the status of the greens and control the behavior accordingly. Using OnSite, it will also be necessary to associate the green phases with each channel using the desired greens section of each channel. In addition, you will need to enable the confirmation light function and set the confirmation light behavior in the confirmation lights section of the general configuration screen. It is possible to set the lights to be off, on steady, or flash for both the called direction and the non-called directions, and for both desired greens displayed versus non-desired green displayed for each called and non-called directions. Please see the OnSite help file for more details on these parameters. For Opticom GPS installations, it is possible to use the GPS clock to keep the clock current on other devices in the traffic cabinet, such as the traffic controller. One of the AIP outputs may be set to send a clock reset pulse to the clock reset input of these other devices, such as the traffic controller. Connect a wire from one of the outputs of the AIP to the controller clock reset input. Then, in OnSite, go to the time synchronization output section of the general configuration screen to set up when the clock reset pulse will be set and which output you are connected to. Be sure to consult your controller manual to determine what time that the controller is expecting the clock reset input. If you are operating in IR mode, you can do what was just described in reverse. You can take a clock set output from another device in the cabinet to keep the clock in the phase selector current. Connect a wire from your external clock source to the EXT clock sync input on the AIP. Using OnSite, you will need to configure the time that the clock sync pulse will be received in the time synchronization input section within OnSite's general configuration screen. Consult your clock set source manual and the OnSite help file for more details. Another way to input or output time synchronization data is through one of the two serial ports on the AIP. Instead of activating a discrete signal, the time sync input or output may be sent or received serially. Connect a serial cable from one of the two ports to the clock sync source or destination in your controller. Within OnSite, go to the General Configuration section. Within the Communications section, notice the COM3 and COM4 options. Here's where you set the baud rate and NMEA 0183 GPS input or output. Consult your controller manual or clock set source and the OnSite help file for more details. The final feature available is the Disable Output Input. This input, when activated, will disable all outputs on the AIP and the phase selector. This feature may be used to prevent EVP and TSP calls from reaching the controller during rail and drawbridge preemption. Of course, if rail and drawbridge preemptions are given a higher priority than EVP input, this feature is not needed. To use, connect wires from the AIP inhibit and control 24 volt to an output of the controller that is activated during rail or drawbridge preemption. Consult the phase selector manual and your controller manual for more details. No configuration within OnSite is needed. The AIP provides many helpful configuration options that complement the basic capabilities of the 764 phase selector by itself. Please contact GTT Technical Support if you have questions about using and installing the AIP in order to optimize your Opticom system.